Hey everybody, it's Jane from Norman S. Wright. Now the last several videos we've been talking about chillers and chilled water, so let's talk about the heating side now, starting with boilers. Let's talk about boiler basics. Let's get started. Let me start by pulling up this image. So I've shown this image of the chiller components that shows chilled water going off to the air handlers, but what about heating? Where does the hot water come from? Well, the hot water comes from the boiler. Let's slide this over and talk about boilers. Boilers are an essential component of commercial HVAC systems. They provide heating and hot water for buildings of all types and sizes. Boilers are typically fueled by gas, oil, or electricity. Boilers are pressure vessels designed to transfer heat to water, either as liquid or steam. As a side note, if the fluid being heated is air, we call it a furnace, which we're not going to talk about today. I'm going to focus on hot water boilers today. Chapter 32 of the ASHRAE Handbook, HVAC Systems and Equipments, groups boilers into classes based on working pressure and temperature, fuel used, material for construction, and whether they're condensing or non-condensing. Let's look at a couple of these categories. Most boilers are constructed to meet ASME boiler and pressure vessel code. This breaks them into high pressure boilers and low pressure boilers. Low pressure boilers are constructed for a maximum working pressure of 160 psig and boiler temperature is limited to 250 degrees F operating temperature. High pressure boilers are designed to operate above 160 psig and above 250 degree Fahrenheit. So I'm going to focus on low pressure hot water boilers that you typically see in commercial applications. Hot water boilers are generally available in sizes from 35,000 to over 100 million BTUH, but commercial applications usually don't go over about 12 million BTUs per boiler. Okay, let's slide this over to make some room. Boilers are either non-condensing or condensing. Let's start with non-condensing boilers. Traditionally designed boilers operated without condensing the flue gas in the boiler to prevent corrosion of cast iron, steel, or copper parts. Hot water units were operated to 140 degree Fahrenheit minimum water temperature to prevent the corrosion and to reduce the likelihood of thermal shock. Thermal shock occurs when cold water enters a hot boiler, and the sudden introduction of the cold water to the hot water causes the rapid expansion and contraction of equipment inside the boiler. This can result in boiler damage or even worse. Now let's move this over and look at condensing boilers. Because a higher boiler efficiency can be achieved with lower water temperatures, the condensing boiler allows the flue gas water vapor to condense and drain. Condensing boilers are designed for operation with low water return temperatures found in hot water reset, water source heat pumps, two-pipe fan coils, and reheat systems. I'll do a separate video on how condensing boilers work. Most non-condensing boilers are made of cast iron sections or steel. Some small boilers are made of copper or copper-clad steel, and condensing boilers are usually made of stainless steel. And they are generally resistant to thermal shock. Hot water boilers can be broken down into fire tube, water tube, and electric boilers. So let's make some room and look at that. In fire tube boilers, the hot flue gases flow through tubes surrounded by water. It looks something like this. So you'll have the pressure vessel shell on the outside and a blower that leads to a burner. This is inside a combustion chamber. And then down here are your fire tube heat exchangers. And at the bottom, this is where the flue gases exhaust. I forgot to draw the burner, so let's do that. So let's label these. So inside this whole orange section would be hot gases. And then we'll label down here where the gas exhausts. So around this, in this area, would be the water that you are heating. And then there'd be an inlet for the water to come in and an outlet for the water to go out. Let's scoot this over a little. I'll bring them all back on screen at the end. And now let's look at water tube boilers. Water tube boilers have water inside the tubes that are heated by gases that are surrounding them. So it's kind of the opposite of the fire tube. So let's look at what that looks like. So again, we'll start with the pressure vessel on the outside, and we'll put the blower over here and the burner right here. And then we'll draw in the tubes of water. So the water would come in down here as cold water and leave at the top as hot water. So essentially all of this section is going to be where the hot gases are. Let's scoot it over again and look at electric boilers. Now electric boilers use electricity to heat water with heating elements. So it kind of looks like this. Again, you have the pressure vessel on the outside. This would be filled with water, and then in the water there would be electric heating elements. And then again you'd have water going in and hot water coming out. So let's pull all of these back on so we can look at all of them side by side. The main components of a boiler are the burner, combustion chamber, heat exchanger, and controls. The burner provides the heat source for the boiler. The combustion chamber is the area where fuel is burned in the boiler. The heat exchanger transfers heat from the burner to the water, and then the controls regulate the boiler's operation, including temperature and pressure. And then the hot water is circulated by pumps through pipes throughout the building. The water enters hot water coils in VAV boxes or air handlers to provide heat to spaces. Hot water can also be used for indirect domestic hot water, pool heating, and snow melt. Okay, let's bring most of this back on screen now so you can see it. So that was a quick overview on the types of boilers and how they work. Don't forget to like and subscribe to our YouTube channel. And thanks for watching.